Hello and welcome back to the 5.3 notes. This is part 2. And I want to go ahead and start a few of these, do some of the examples, some of the things that you'll see on your exams and some other concepts that we need to go over. So the first thing I want to do is take this idea of the limits of a finite sum, and I want to express those limits as definite integrals over the given interval AB. So the first thing that I would do is I would take this finite sum, take the limit of it, and what this gives me is this gives me the integral from -1 to 0 of 2x cubed dx. And so all I'm doing is just rewriting these in integral form, okay? And I want you to note that the x sub k, okay, when I use it in the sigma notation, I have to do the sub k because that tells me what x value I'm using. Okay, same thing with delta x sub k. But when I take this limit, the x sub k becomes an x in both the function and the change in x, okay? And then this is my lower limit, that goes down here. This is my upper limit, and this goes up here, all right? In example 2, same thing, okay? The limit of that finite sum becomes the infinite sum of between 1 and 4 of 1 over x dx, okay? And so I just need to take what's inside of here and rewrite it just with an x, okay? All right, the next thing to talk about is displacement and net area. Displacement is a physics term that we use to show the distance from your origin. Okay, this is distance from origin. Okay. It's also kind of thought of as your position. Okay. And so, you know, in the previous videos, I was talking about the total distance traveled. And that is something that we will continue to do. But displacement, the reason why I was talking about the total distance traveled was to get you guys to understand the concept of what it means to calculate the area under the curve or area under a graph. But we're going to take this a step further and talk about something called net area. Okay, and net area means that we're going to use both positive and negative areas. Okay, so I want to take a look at the example of throwing the object in the air and letting it fall to the ground. I just have my position function, my position and my velocity function. Remember, my position is my f of x, and velocity is my f prime of x, okay? And so what I want to do is I want to think about this function, and what I know is that when I throw the object in the air, it takes 2 seconds for it to reach its maximum height, and then 2 seconds for it to fall back down to the ground, okay? We have a maximum height, so I'm going to come in here and say that our maximum height, okay, max height is 19.6 meters, okay? And so here our height is 0, okay, when we start, and then after 4 seconds, our height is equal to 0. So height is equal to 0, all right, at 0 and 4. So, but when I look at my velocity function here, what I notice is that, you know, our velocity is decreasing, okay, or the object is slowing down, it stops at 2, and then it speeds back up. Okay, so what I want to do here real quick is I want to calculate the area between 0 and 2 under this graph, okay? So that area, the area between 0 and 2, so I'm going to write that as an integral. I'm going to say the integral from 0 to 2 of f prime of x dx, okay? And the question is how far did that object travel between 0 and 2 meters? And we can take a look at our position graph here, and we know that over 2 seconds, we have traveled a distance of 19.6 meters, okay? So this is 19.6 meters, okay? Now, let me ask you this. If I wanted to calculate the area between 2 and 4, this graph is below the x-axis, okay? And so the question is, if I integrate from 2 to 4 of f prime of x dx, then I have traveled a distance of 19.6 meters. But you have to think about something. We have to think about the direction here, okay? When my graph was above the x-axis, our height was increasing, okay? But when we were below the x-axis, my height was decreasing. So what this ends up giving me is a length of negative 19.6 meters, okay? Which is kind of weird. And we can't talk about distance and length having a negative value, but we have to talk about the displacement, okay? We have to talk about its position, okay? So what I want to say here is that our area under the curve, okay, if it's above the x-axis, is positive area. And if it's below the x-axis, then this is negative area, okay? So positive area and negative area, okay? Now, what I've done is I've shown you how, what these values become if we were to, throw the object in the air. It travels 19.6 meters, and then it travels down 19.6 meters. So the question is what's the area from 0 to 4 of f prime of x dx? Okay, what's that area? Now, I would, if this area down here is positive and this area down here is negative, and they're the same area, then this gives me an area of 0, okay, under that curve. But you have to think about what is this question asking us? It's really asking us for the displacement between 0 and 4, okay? I know that in previous chapters I talked about how when you integrate the derivative, that gives you the total distance traveled. And that's not really correct. We'll talk more about the total distance traveled as we move further and further on with integration. But this really means displacement, okay? Because when I calculate positive and negative area, it gives us our position. And we have to think about, okay, what is our position after 4 seconds? How high off the ground is the object? And the answer to that question is 0, okay? So hopefully that makes sense, positive and negative areas. And so what I do want to do now is talk about some properties of definite integrals. And what I know, I'm going to let you guys kind of read through these. And we'll do a lot of practice with these. But we have a zero-sum property of integrals, that if we integrate between a and a of a line that doesn't have any area, it's 0. If we switch the bounds of our integral, then the entire area becomes negative, okay? If I add or subtract integrals, then we can, of different functions, then we can take each of those separately and add them together. The most important one, the one that we'll use the most, is number 4. And this is the constant multiple. And that's when if you're taking the integral of a function and you have a constant multiple out front, then we can pull that constant out front and multiply it by that area, okay? And then the last one, we can split up the values of our integration and integrate over an interval, okay? So this may or may not make total sense to you right now, but it should hopefully make a little bit of sense on the next page. All right, so if we take a look at example 3, it gives us these conditions here. Okay, and it says that the integral from 1 to 9 of f of x dx is equal to negative 1. And it says that the integral from 7 to 9 of f of x dx is equal to 5. Okay, we have this other option, or this other function here, h of x, that gives us another area of 4. But here's what we need to do. Okay, you have this. But you need to sit there and ask yourself, what does this mean? When I have an integral of this function, okay, over this interval, what does this 5 mean? Okay, and so what I'm going to do is I'm going to draw a picture of what this looks like. Okay, I'm going to draw a graph, and I'm going to put the values of 1, the value of 7, and the value of 9 here. And the one I'm going to start with, because it's the one that makes the most sense, is the integral from 7 to 9 of f of x dx is equal to 5. Now, what this means is that the area under the curve between 7 and 9 is 5. So I'm going to come in here and draw some curve between 7 and 9 above the x-axis because it's positive. Okay, I'm going to kind of color that in red. And I'm going to come over here and I'm going to say that this area is equal to 5. Okay? So when you see this, then you need to go through and draw a picture and understand that the 5 means the area under the curve of f of x. I'm going to say that this is f of x. Okay? That the area under f of x between 7 and 9 is 5. Okay? Now, they went ahead and gave us this other condition that the integral from 1 to 9, so that includes 7 to 9, is negative 1. So wait a minute. What you're telling me here is that if I add up all the area of this function from 1 to 9, that it's going to end up being negative. Okay? Now I know that this area had to be 5. So then the question is, what's the area from 1 to 7 under f of x? What would that have to be? So what do I have to add to 5 to get negative 1? And the answer is negative 6. Okay? But because that's negative, that means my function has to be below the x-axis. Okay? And I'm going to color that in with red. And I'm going to say that this area is equal to 6. But this area is negative because it's below the x-axis. And this area is positive. Okay? So that's the idea. All right? We need to be able to draw these functions given what we're given with these integrals. Okay? Now, the other one that I'm going to do is I'm going to do the one for h of x. So I'm going to draw that function. And that we're only given the information from 7 to 9. So from 7 to 9, and I'm just going to draw a quick little graph here. And I'm going to call this h of x. And I'm going to say that the area here is equal to 4. Okay, so we need to be able to draw a picture, all right? Given something like that. All right, so now what we want to do is we want to use the rules that we just learned in the previous one. I'm going to show you how to use those. And then I also am going to, but we need to use these pictures to help us answer some of those questions. Okay? So I'm going to zoom into part A. And part A says we want to evaluate the integral from 1 to 9 of negative 2 times the function f of x. Now, this is a constant multiple, okay? And how I like to think about it is I like to pull that constant out. And I'm going to write negative 2 times the area from 1 to 9 of f of x dx. Now, what we know is that the total area, the total accumulated area between 1 and 9 of f of x dx is negative 1. Now, it tells us that here, but we can also just add these two together, and we know that this is negative 6 plus 5 gives us negative 1. So now the area from 1 to 9 is negative 1, So I'm going to write it like this. I'm going to say negative 2 times negative 1. And so if we evaluate that integral, that gives us an area, or gives us a value of 2. Okay? So we can manipulate these areas. All right? Okay, part B is the integral from 7 to 9 of f of x plus h of x. Now what I want to do is I want to split this up. And I want to say the integral from 7 to 9 of f of x dx plus the integral from 7 to 9 of h of x dx. Okay? Now we knew that the area for f of x was 5. Okay? We can look at that from our picture. And the area under h of x was 4. It also tells us here and here. So I can replace those values now with 5 plus 4, and that gives us a total area of 9. Okay? All right, now let's combine parts A and B to do part C. And I'm going to stop the video at that point. But what I've got here is I've got the area from 7 to 9 of 2 times my function f minus 3 times my function h. So I'm going to rewrite this. I'm going to split it up. And I'm going to say my integral from 7 to 9 of 2 times f of x dx minus the integral from 7 to 9 of 3 times h of x dx. Okay? Now, the other property that I have is that I can pull out that 2 and pull out that 3. So I'm going to do 2 times the integral from 7 to 9 of f of x dx minus 3 times the integral from 7 to 9 of h of x dx. Okay? Now, we knew that the area under f of x was 5. Okay, and the area under h of x from 7 to 9 was 4. So I'm going to replace those with 5 and 4. And so we end up getting this. We end up getting 2 times an area of 5 minus 3 times an area of 4. And that's going to give us 10 minus 12, which gives us a total area or evaluation of negative 2. Okay, I'm going to go ahead and stop this video, and I'll do the rest of the problems for part 3. So thanks for watching. See you in a bit. Bye.